Okay, chapter 9. Warning. I intend to complete this chapter 9 in 3 hours. That means 3 periods, 3 lectures. In these 3 hours, there will be 3 tutorials. Because after we complete this one, every hour there will be 1 tutorial. So there will be a lot of tutorials to do. Okay? Okay? But you must listen. If you don't listen, then you cannot do the tutorial. Okay? There will be tutorial 9.1, 9.2, and 9.3. Okay? All the best. Alright. The first tutorial is about tangent normal. The second tutorial is about rate of change. The third tutorial is on maxima minima. So there are 3 parts to it. Okay? So this chapter is broken up with 3 parts. Tangent normal, rate of change, and maxima minima. Okay, never mind. Don't know what it means also, never mind. Let's start. Tangent normal. Thank you. Suka. Thank you. Okay. You have a curve like this. You have an equation of a curve like that. Y equals fx. Suppose I consider a point P. Thank you. Suppose I have a point P. Are we able to find the tangent at P? In fact, are we able to find the equation of the tangent at P? That's our job. Can? Can, right? Okay, how? First, I let the gradient of the tangent to be m, gradient of the normal to be k. Okay? Tangent, tangent is this one. Oh, maybe I use a different color. Tangent is this one. Correct? This is m. Normal is this. Normal is this one. Okay. Can? You all know what's tangent, what's normal, right? Do we know how to find gradient of the tangent? Does it mean that m? Do we know how to find the gradient of the tangent? Thank you. Gradient of the tangent is the value of dy dx at x equals to x1. Does it make sense? That means you differentiate. You differentiate first, then you substitute a specific value, x1. Okay, later I'll give you an example, but now it's like that. Make sense? You substitute the value x equals to x1. Now, then how do we find gradient of the normal? Now, gradient, the tangent and the normal are perpendicular to each other. So does it make sense then that since mk equals to -1, this is because this line and this line are perpendicular. This is what you learned before. Alright, the gradient of the tangent times gradient of normal must be equals to -1. It means that k must be equals to -1 over m. Therefore, k is just -1 divided by our dy dx at x equals to x1. And now I'm using x1 and y1. Later on, I'll use specific numbers and you can understand a little bit better. Alright? So, I can easily find, if I know what is the function f, I can easily find gradient of tangent. I can easily find gradient of normal. These are just numbers. I'm not sure whether you are familiar with this form. Y minus y1 equals mx minus m1, x1, sorry. Familiar or not familiar? Or are you just familiar with? Okay, I give you an example. Easier. Oh, look up. I want to be very clear. Let's say I tell you I have a point 2, 3. Okay? And I tell you the gradient equals to 3 over 2. Gradient of this line. Can you find the equation? Cannot. Equation is this. Y minus y1 equals to mx minus x1, where this is x1, this is y1. That means the equation is y minus 3 equals to 3 over 2 x minus 2. You familiar with this idea? Familiar with this idea? Can I? Okay, so if you are familiar with this idea, then the equation of the tangent is y minus y1 equals to m is the gradient of the tangent, x minus x1. Normal is y minus y1 k x minus x1. Okay, don't want to say too much. We must move on with the examples, then you can understand a bit better. 9.1.2. This idea may not be very clear to all of us, but I want to emphasize. Does it make sense that the gradient of the line is actually tangent theta, where theta is the angle it makes with the positive x direction? Look up. Doesn't mean not. Oh, you got a problem. I noticed that they're starting to copy. There's a lot of talking. You want like copy, is it? Then I let you have more blanks next time. You like copy? Now, gradient of tangent, gradient of a line. Let's say I tell you the gradient of this line is equals to 2. Correct? If gradient is 2. Gradient 2 means what? Means this is 2, this is 1. Does it make sense? Correct? Does it then mean that tangent theta is 2? Correct? Tangent theta is 2 because opposite over adjacent, tangent theta is 2. So actually, tangent theta is the gradient. Make sense? Alright, so gradient of the line is tangent theta, where theta is the angle it makes with the positive axis, x-axis. Okay? This is a simple example to illustrate. But what if it is parallel? If it's parallel to the x-axis, that means a horizontal line like that. Obviously, gradient is 0. If it's a vertical line, gradient is undefined. Make sense? Okay, example. Don't say too much. All printed for you. Nothing to say. I give you 30 seconds to read through on your own. Just read through on your own. I have nothing to say, really. You must make use of your own. Self-learn a little bit, okay? Read through. It should make sense. Okay? All you need to do is differentiate and start in numbers. All good? And easy? All you need to do is differentiate, sub numbers in, you're done. GC method. Are we able to use GC? Are we able to use GC to find gradient or rather equation of tangent? Now very quickly I illustrate. Do I need to show you? No need, right? You all know already, right? Oh? Okay, so I don't want to go through, right? Just take note, there's a slight typo. Here, there's a negative that's missing. You please add in the negative. Okay, let's move on to example 2. I want to say a bit more about example 2. All right. For the curve, this Find the equation of the tangent at 2, 0. Now let's observe this equation carefully. Let's observe this equation carefully. This equation is interesting because there is a y square, there is an xy here. Correct? And look at this comment. You should be able to observe on your own. There's a y square, there's a y. It will be very difficult to make y the subject. It will be very difficult to make y the subject. So therefore, we do not encourage the use of GC. It's because it's tedious to make y the subject. What? If you can't make y the subject, does it mean that you cannot proceed? No, because you can still use implicit differentiation. Got that? So can we practice using implicit differentiation? Those of us who want to practice, you can go a bit faster and do it on your own. Differentiate 2x squared, you get 2x. Differentiate y squared, you get 2y. Not done yet. You must use chain rule to differentiate y squared, you get 2y dy dx. Correct? Because you are differentiating with respect to x. Correct? Differentiating with respect to x. Plus. Now, this one, you must use product rule, right? 2xy, you must use product rule to differentiate. Yes? So, you keep 2x, you differentiate y, you get dy dx. You differentiate 2x, you get 2. You keep, you get 2y. Differentiate 4, you get 0. Differentiate 0, you get 0. You get this. This is an important line. This one we must recap what we learned in chapter 8. Is that right? So, this is what we get from here. Whoa. By using product rule, you get this. Yes. Sorry, say again. 2x. Oh, first term. Oh, sorry, 2x. What am I talking about? Sorry. This is 2x. Thanks. Okay. Having gotten that, we want to find, remember what we want? We want the equation of the tangent at this. So therefore, we need to find what is the value of dy dx, which is the value of the gradient of the tangent at 2, 0. All you need to do is to substitute 2 and 0 in, we get our answer. Which means this. You substitute x equals to 2, you get 4. Minus, y equals to 0, you get 0. Plus, plus 4 dy dx plus 0 equals to 0. That means dy dx must be equals to -1. Now we know that gradient of the tangent is -1, and you know that it passes through 2, 0. Correct? So you use the idea y minus y1 equals to mx minus x1. Y must be equals to minus x plus 2. Done. Got that?